Okay, so today what we're going to do is we're going to be talking about some of the conventions in algebra. Now, you might not use the word convention very often, but convention is just a way of doing things, right? An agreed upon way of doing things. So, for example, in New Zealand, if you're driving a car, which I'm hoping not enough of you are doing right now, which side of the road do you drive on?
You guys know the class to drive is fine.
The middle. Drive in the middle.
Drive in the middle, okay. It's your left, your keep left. Oh. Which is yet another reason why I'm very glad. Guys. Now, so that is one reason why we have conventions. What would happen if you just decided, today I want to drive on the right-hand side? Right. It's dangerous, right? And so you're going to see that in mathematics in particular, there are lots of times when specific conventions are observed to make sure that everybody is doing the right thing, right? So these rules are very rigid to help you, not to make it worse or harder on you, right? So we're just going to go through the Education Perfect lesson and we'll mention some things. And you can take some notes about some things that I circle or I talk about, things that are going to be very important about it. But I want you to be able to see some examples as well as we go. So I'm going to use this lesson. All right. So we've seen what variables and expressions are. What is a variable, you guys? Should just shout out. So is it some letter that's used to represent an unknown number? Exactly. Good. Okay, excellent. Good. So and they're called variables because their value can vary. Yeah? So like yesterday we talked about the wind. Does the wind always blow at a constant speed? No way, right? So the wind is a variable. Good. We also talked about the idea of an expression. An expression is simply a collection of
numbers, variables, or operations.
Numbers, variables, and operation symbols. Good. Numbers, variables, and operation symbols. So you can still have pluses, minuses, addition, subtraction, multiplication, division, right? You can have A's, you can have B's, you can have 4s, you can have negative 2s. Any combination of those can make an expression. What can you never have in an expression?
The equal symbol.
The equal symbol. Excellent, guys. The equal symbol, because that would turn it into not an expression, but an equation. Excellent job. Okay? So mathematicians over the years have invented rules that help to simplify expressions, right? So, for example, if you wanted to name every student in this class, right, you would not just, and you wanted a nice list that someone else could read, you could just make a list looking around, right? But would it be possible to miss somebody? Sure. Is it easy to read a list if it's just a list of random things all over a page? No. But when we make a list of people's names, we put them in alphabetical order, perhaps, to make it easier. Okay? All right? Let's say I want to list the letters of the alphabet, but I don't want to put them in order. Could you list all 26 letters of the alphabet if you didn't use alphabetical order?
Well, yeah, you could do every second one, and then go back and do every one.
Or you could do it
Perhaps. Some people could. But I guarantee that most people cannot say the alphabet without using alphabetical order. Even though they know all the letters, it's easy to forget them.
You just say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V.
You're in alphabetical order except for point 1, so that's not the same thing. So you see that having a pattern, having a way of ordering things is really important. It makes it easier for us to remember. Okay? And makes it really very clear. All right. So, we call these rules conventions. Right? Because it's just the conventional way in which we do something. Right. So the convention is just kind of the proper way of doing something. And we talked about this one. In New Zealand, you follow the convention of driving on the left-hand side of the road. If you weren't lines on the road and you just decided wherever you wanted to drive, then it'd be chaos, right? Kind of like there's a convention in this classroom that when I'm talking, I expect you to pay attention and not talk, right? What happens when that convention breaks down, which happens more frequently than I'd like?
It's a hullabaloo.
Y'all don't learn. I go crazy. Things are it's just a mess, right? Okay? So it's very important. All right. One of the conventions in mathematics is something that you've been taught since the beginning of your multiplication tables, and that's what happens when you multiply a number by 1. Do you remember that anytime you multiply a number by 1, you get the number
Even if it's the other way around.
itself, right? So 3 times 1 is 3, 1 times 3 is 3, x times 1 is x, y times 1 is y. It doesn't matter. You can multiply anything you want to by 1, and you get exactly the same thing you started with. Do you agree? Yeah. Now, that may seem really simple, a really simple concept for you, but it's huge. Because it allows us to do things that we wouldn't be able to do otherwise. Like add fractions that are not alike. And do lots of other things, okay? So it's a really important concept. So no matter what order you do it in, you get the same result. Now, is that true of all multiplication? That if you multiply in any order, you get the same result?
Yeah.
So 2 times 3 is the same is what?
6.
Well, what's 3 times 2?
6.
Doesn't matter, does it? Okay? How about addition? 2 plus 3 is 5. 3 plus 2 is 5. Okay. Does that work for every operation?
No.
What operations does it not work for?
Division and subtraction.
Division or subtraction. Good. Yes. Right. Those two operations, the order makes a huge difference. Excellent job, guys. Okay. Now, you see this word simplify quite a lot. Anytime you see the word simplify simply means do the math. If you can do the multiplication, you need to. If you can add two things together, then you need to. Can you always add things together? No. So do whatever you can, following the rules. Okay? And what is the rule for simplifying? There's a mnemonic device. It's called the order of operations. Good. Remember that. Yeah, it's very important that you remember the order of operations. So simplify also means apply the order of operations. They're identical. Okay, here we go. Now, so they show you this using physical objects just so we can make sure we have this task down. If you look at the top, what we have is we have 3 lots of 1. Do you agree?
Yeah.
But if we put them together, don't we still have? Yeah, we have 1 lot of 3. But they mean exactly the same thing, don't they? Okay? So you can break things apart. They're just the same as saying we have how many? 3. Okay? Good. So you see that the order and the way you say things doesn't matter. Okay? Now, here they're looking at using a variable. If you have 2 lots of y and you took 1 away, if you have 2 and if you start with 2 and you take 1 away, how many do you have left? 1. So 2 y's minus 1y would still leave you with 1y. Right, okay? But we don't like to say 1y.
Just say why.
We can just say y. Just say y. Exactly. Because think about it. This object is a pen, right? Well, don't I say one pen? No. If I just say I have a pen, you automatically assume it means how many? One. So, if you have an x, you automatically assume that means how many x's? One of them. If I have an AB, you automatically assume that means how many of them? One AB. Right? Doesn't matter if you have more letters. It just means one. What is that number in front that tells how many called? It starts with a C. The coefficient. Do you remember that? Okay, we haven't really talked about it again lately, but it's called the coefficient. We've introduced it before, but that's okay. Just thought I would try to stretch your minds there, but that's no big deal. Okay? Good. All right. Well, the next topic we want to talk about, we want to talk a little bit about multiplying variables. Okay? Because remember that we have all four operations in algebra, but we now have numbers, right? And remember that numbers have a specific name now. What do we call those things? Constants. Remember, they stay the same? Constants. So numbers or constants means the same thing. Why is 4 a constant?
Because it doesn't change.
It can't change. It's always a 4, right? So you see the idea behind calling them constants. And then we have variables. And why are they variables? Because they vary. They can change, right? Depending on the sentence they're used in. Good. Okay. Well, so we built a new system. We also have different operations. Now, are there new operations just because we're doing algebra? No. But there are new ways of writing them because we're doing algebra. Because now we don't have just numbers. We have numbers and variables or letters, right? Or constants and variables. So we have new things to write with. So we can write things in a different way. And the one that changes the most is the operation of multiplication. There are lots of ways of writing multiplication. Now, traditionally in arithmetic, now this is not arithmetic because it has what in it right here? A variable. But in arithmetic, the traditional symbol for multiplication is what? An X. Why do I have trouble now using that X for multiplication?
Because we have the unknown number X.
So exactly. I don't know if that's X the multiply or if that's X the variable. Now, when they type it very neatly, and a very, very, very straight-sided X means multiply, and the X with the little squigglies means that's the X, the letter, right? Do you type when you're with your pencil? No. You could write very neatly, but do you have the time always to think about that kind of thing? I mean, is that our focus to try to cheat the system? No. So instead, what we're going to do is we're going to use different ways of writing multiplication. And one of the most common things to do is to simply replace that X with a dot. Now, it's not as common in European and other countries like South America because many of them, when they have a decimal, say 3.5, they put the decimal very high. And so sometimes it's difficult for them to see that a dot means multiplication. So, as a rule, we don't usually use the dot, but you can. right? Now, if I wanted to write 4 times a, the easiest way is to simply write them side by side. So if you see 4 and an a side by side with no operation symbol between them, what operation does that automatically mean?
Multiplication.
Multiplication. So what I'm about to write is huge. Very, very important idea to you. Okay? So, right, I need you to pay attention and make sure that you ask if you don't understand what I'm going to say, what I'm saying. Okay? So here's the deal. Oops, changed it. I don't want that. And I certainly don't want yellow. Let's try again. Multiplication is the only operation out of how many?
4.
4. Thank you. Good. That requires no symbol at all. It's the only operation that requires no symbol at all. And that's what allows us to write this 4a. So if I have 4 and an a shoved together like that, with nothing between them, I must conclude what operation?
Multiplication.
Multiplication. Do you see it? Okay. Now, that brings us to the other side. If it's true one direction, then it must be true the other direction. All right? If you have a rule, it has to be true both directions or else it's not true. So, if you see no operation symbol, you must conclude that it means what operation? Multiplication. Excellent. Do you see what I'm saying by backwards and forwards? If there is no symbol, then you must conclude it's multiplication. If it's multiplication, you don't need a symbol. So you see? Back and forth. Okay? That's how you know it's true. It works both ways. Okay? So, if I see 3ab, there are 3 things there, right? So that means what? 3 times A times B. All 3 of those things are held together with multiplication. Do you see it? Yes.
Could you do A for B?
What? I'm sorry?
Like, could you mix up the numbers?
Could you mix them up? We'll talk about that in just a moment. That's going to lead right into what we're about to say. We're about to think. So, yes. Yes.
Aren't some equations have 2 variables? So if it was, like just one to represent one number, it might just have A, B as one variable together.
Right. But because they're together, that means what operation is holding them together? Multiplication. Yes, you can see them together. Now, what if I had 3 plus AB? Does that all mean multiplication? No. Because of this addition symbol, that means it's not all multiplied together. Are there any things in that expression that are multiplied together?
Yes. A times B.
The A and B are, right? Just not the 3. Do you see it? So if there's a symbol separating them, then they're not multiplied together. How about if I have negative 2x? Does that mean multiply?
Times X.
Yes, because this negative is not a subtraction symbol, it's the sign of the 2. So this means negative 2 times the x. Okay? It's looking good? All right. Another way that you can write multiplication is by using parentheses. If you have a number or a letter right in front of a parentheses, do you see a multiplication? Do you see any symbol between the 4 and the parentheses?
No.
If there's no symbol, then what does it have to mean?
Multiplication.
Multiplication. You bet. You could also have them both in a parentheses. And you'll see a lot of this later when you move into the higher grades working with algebra. Do you see anything between the two parentheses? Which means that it means what operation? Multiplication. Pretty happy with that?
Yes.
So you're never going to forget it ever again, right?
Hopefully not. Parentheses.
It could happen, but hopefully not. Okay? Good job. All right. You can simply leave out the multiplication symbol. Now, they still put it in a lot in Education Perfect, which is fine. And it's fine if you do. But then it's going to go away. And if you don't understand why it went away, then it could cause some trouble for you. Okay? All right. So instead of saying 4 times x, what could I say?
4x.
4x. Excellent. Good. Okay? All right. Now, here's something like the question that you were asking a moment ago about the order. See, notice that we have this one says 4x and x4. One of the conventions is that the number part always comes before the letter. Okay? It just keeps you organized. Right? Do you have a first name and a last name?
My last name is first.
Okay. Do you say your first name first or your last name first?
First name.
Yeah, so, yeah. Well, I'm talking about you. Okay, so, right? And so you would confuse somebody if you walked around and you said, my name is... There you go. Davies Gabby. Right? Hi, I'm Davies Gabby. So what, Audrey, if she said, hi, I'm Davies Gabby, what would you say? Oh, you're right. But you would think that her first name is Davies, right? So you see? So it's important. It's important that you observe convention and put them in the right order. And so it's guys. All right. Okay. So x4 literally means the same thing as 4x. It just looks better that way. How's that? It wouldn't be wrong right now, but later it would cause you a lot of trouble.
Okay.
All right? So just get in the habit of putting it in the right order. Okay? All right. Another reason why is because when you have exponents, if you have x to the third, if I wrote that as x3, which one of those is the exponent? It's the top one. But do you notice that one looks very similar? So it can get really difficult when you have exponents, knowing which one's which, especially the way some of you write. Because some of you just aren't as neat and tidy as I am, Okay. Like I'm neat and tidy. Okay, so, oops, there you go. I don't know why that's in. So just if you see a variable after, then put the number where? First. It's number, then the variable. Okay? Even though we know that literally in the mathematics it doesn't make any difference. But just to keep it neat and organized. Okay? All right. Now, do I always get to leave out a multiplication symbol no matter what? No, because if I have 3 times 6, I can't just call that 36. So I'm only allowed to do it when I have a number or a variable times another variable, right? So this is an algebra thing. This is arithmetic. Algebra rules do not apply in arithmetic, right? So don't get confused about it. If you're doing a different system, then you can't use those rules. Okay? So, 7 times b. What would you write? Just 7b, right?
Are we allowed to use brackets for if it was two numbers, like 7 times bracket 6?
Yes, absolutely. That's a way to write it.
Bracket 6?
Sure. So you could, because a parentheses always means multiply. So she's saying, what if I had this? Now that's perfectly fine because the bracket is a multiplication symbol because there's nothing between the 7 and the multiple. Now, could you do this and mean multiply?
No.
No, because of the plus between them, it no longer means multiply. Okay? Good. All right. Let's see. What else is on this lesson? Dividing variables. Now, multiplication changed a lot, right? 4 times a, we don't use the x anymore. We just cram them together. Division changes a bit as well. Whoa, hold on a moment. Okay, so division, now we can write it with the fraction bar. So a couple things can happen. Say we have 8 over 4. Literally that means 8 divided by 4. Can you divide an 8 by 4? Yes. Sure, you get what?
2. 1/2.
Oh, be careful. 2. Okay? Now, what if I have 3 divided by 5? Can I divide a 3 by a 5? No? Not without changing it to a decimal, which is not a good idea. If you start with fractions, you usually use fractions, unless you must do more mathematics with it that requires you to change it. Okay? So it just stays 3 over 5. What if I have this one? 4 divided by 8. Can you divide a 4 by an 8? No, it's too big. But both of those numbers will divide by 4. So in other words, we can simplify or reduce this fraction. So what's the completed answer? 1/2. And you must take it to there or it's wrong. 4 over 8 is not correct, right? So if it will reduce, then you must reduce. So these are the 3 things that can happen with you when you're dividing. You can divide it, you can't divide it, or you can simplify it. Right? So, but in all the cases, we're replacing the division symbol with what? The fraction bar. Now, another thing. Now, sometimes when you're typing, you really don't get a choice. I understand that. I will be forgiving on that. But if you're working in Education Perfect, often they give you a template, right, to use. I want you to use the template because this is a fraction. This is a notation. This one means A divided by B. This one is the algebraic notation for A or B. Just like in English, that forward slash means or. So, if you have no choice at all when you're typing something in, but to use this, it's an acceptable answer. If you're writing it by hand, your hand is not a typewriter. So if you're writing by hand, I expect that fraction bar to be flat. So if you write 1/2 and think that's 1 divided by 2, I'm going to go, find myself some nice red ink and go like that. Why?
Because it's wrong.
It's wrong. It literally means 1 or 2, and that's not what you have. Okay? So be careful. You should do it properly. And let me show you, it's not just about me being picky. It's about developing good habits for the future. Because later, you could have fractions that look like this. Let me just get some room. I'm not trying to scare you, but I just want to show you what can happen to you. I could have a fraction that is x divided by x squared plus 3x minus 2. Okay? It's not hard to work. But this one you can't work because there's nothing to do. But if you did this, you've changed the meaning. That says divide that part, but not the rest. Doesn't it? So you can't use the slash later anyway. See, so this is wrong. Use the flat fraction bar. And if you get in a good habit, when you just first start, what happens?
It keeps on going forever.
Keeps on going forever, right. But what happens if you get into a bad habit? Then you have to break it.
It still has to.
It's hard to break a bad habit, though, isn't it?
Yeah.
Okay? Just ask me about chocolate. Okay.
Who doesn't like chocolate?
All right. So look at this one. We have 3 pizzas. They're all divided by 4. So that's the same as saying 3 divided by 4 or 3 over 4. Right? Good. Right? Here we have P divided by 4 because I don't know how many pizzas. So that's P over 4. Excellent. Okay? Now, 1 divided by 2 equals 1 over 2. X divided by Y equals X over Y. Good job. 3X divided by 7Y?
3x over 7y.
3X over 7Y. Right. You happy?
Yes.
Okay. So I'm going to reopen this assignment. If you've already done it, you do not have to do it again technically. So it doesn't have to be an assignment. If you don't want to do it, don't do it. If you're comfortable with the material. But remember, we're going to use these ideas. So if you've forgotten a bit because we had the pattern stuff in between, then you might want to do it. You don't have to, but you can. Okay? Does everybody understand that?
Yeah.
Okay.